On Wednesday, a team of astronomers announced that they had discovered an Earth-like planet, Proxima Centauri B, and that the planet is likely rocky, has a mass similar to Earth's, and sits in the Goldilocks zone where liquid water could exist. On its surface, the Southern European Observatory stunned everybody with this announcement. This planet in question is our star's closest neighbor, 4.22 light-years from Earth, or nearly 25 trillion miles. Scientists said that it is 4.6 million miles from its red dwarf star, or just 1/12 of the distance between Earth and the Sun, creating a stunning orange sky with no blue. Thus, it appears to be in a perpetual sunset. That is not enough. The planet orbits its stars so quickly that its 1-year mark is roughly 11 days. The planet does not rotate. So, one side is always facing its star and the other side is always dark and colder. X-rays and ultraviolet light are hurled at it. But that would not necessarily be fatal to life, since life can exist underground as well. In the past 20 years, scientists have found more than 3,000 planets outside our solar system, also called exoplanets, and more than 40 of them seem to be in a habitable zone. The James Webb Space Telescope has once again delivered a revelation that shakes our understanding of the cosmos, sending shockwaves through the astronomical community and beyond. This time, it has turned its attention to Proxima Centauri B, a rocky exoplanet orbiting the diminutive Proxima Centauri, a little over 4 light-years away from Earth. What it found has left scientists in awe. Staggering 270% surge in what can only be described as urban lights on the planet's night side. These unusual light emission patterns are not natural auroras or stellar reflections. They mimic the specific frequency range and surface patterns that on Earth are exclusively associated with widespread artificial illumination. The implications are immense, bordering on revolutionary. Before we start, smash the like and subscribe buttons for more updates. Proxima Centauri B has been a planet of interest for decades. Slightly larger than Earth and located in the habitable zone of its parent star, it has long been a candidate for potentially supporting life. The planet's proximity alone made it a prime target for observation, especially once the James Webb Space Telescope was launched and fully operational. Earlier scans of the planet revealed tantalizing hints, moderate atmospheric retention, possible temperatures, and even the potential for water. But none of those clues prepared scientists for this most recent discovery. Light patterns that appear, disappear, and fluctuate across a planetary nightscape in a manner far too regular and intense to be explained by geological or meteorological phenomena. A routine spectral analysis aimed at identifying signs of vegetation, mineral signatures, or atmospheric composition was the catalyst for the discovery. Instead, what emerged was a pattern of focused optical emissions in clusters radiating with a consistency that indicated a fabricated origin. The emissions aligned with wavelengths common to high-efficiency LED lighting, the kind often used in modern urban infrastructure on Earth. More curiously, these lights weren't static. Over a few weeks, the instruments aboard the James Webb Telescope recorded a pronounced spike, a 270% increase in the luminous output across particular regions of the planet's nighttime side. This was not a flare or a brief phenomenon that followed. Daily routines and distribution grids that looked like cities, suggesting a system of organization below the clouds. Understanding these findings required careful elimination of natural causes. Could the increase in brightness have been caused by volcanic activity, auroras, or reflective ice formations? All these possibilities were methodically ruled out. The physical arrangement of the lights resembled urban sprawl with dense nodes of brightness interlined by linear features that appeared to resemble roads or thoroughfares. All right. The geometry was unmistakably non-random. In addition, this sudden increase in luminosity suggested a recent event or a rapid escalation of activity, possibly industrial or even celebratory. It was as if the planet or something on it had collectively turned on the lights in a grand gesture, either to signal outward or for its own purposes. Such a luminous surge cannot be casually dismissed. On Earth, a sudden 270% increase in nighttime lighting would indicate a significant expansion in infrastructure or a dramatic cultural or technological milestone. Could Proxima Centauri B be undergoing a revolution in manufacturing or something far beyond it? The magnitude and rapidity of the change suggest an existing civilization well-versed in manipulating its environment. There is no evidence of hesitancy in these light emissions. They beam outward with confidence, spread in calculated symmetry, and occupy surface regions equivalent to entire continents. This isn't just light pollution, it's planetary illumination. Astrobiologists, sociologists, and physicists are now parsing the data in ways not previously considered practical. If these lights are controlled by an intelligent civilization, the implications stretch far beyond the realm of astronomy. For one, it fundamentally alters our place in the universe. The Great Silence, the Fermi paradox, has fueled long-running debates about extraterrestrial intelligence. But now it seems that the silence may have been a result of technological limitations rather than cosmic isolation. Proxima Centauri B's lights serve as a counterpoint to centuries of doubt. They are not a whisper, but a floodlight. Speculation naturally turns to the nature of the beings or systems responsible for this illumination. Are they biological, mechanical, or some synthesis of both? The energy required to generate such extensive lighting implies a civilization with significant power manufacturing capabilities, perhaps harnessing geothermal, solar, or even fusion sources. Their influence over planetary-scale infrastructure could mean they have achieved a level of technological integration and coordination that far outstrips even the most advanced cities on Earth. The lights don't flicker with instability or scatter like unplanned development. Rather, they radiate with purpose. There's also the question of motivation. Is the uptick in light accidental, utilitarian, or an intentional beacon? Civilizations capable of broadcasting planetary-scale light must also understand the implications of doing so. Light travels. It announces presence, pierces the gloom that hides one's existence from the cosmos. If Proxima Centauri B is now visible as a point of artificial light to telescopes across the galaxy, perhaps that is exactly what its inhabitants desire. Maybe the surge is a declaration, an invitation, or a message, a handshake across the stars, extended into empty space. The scientific community now finds itself confronting a shift in perspective. Never before has such strong indirect evidence of intelligent activity been observed beyond Earth. It's not a radio wave that might be a glitch, or a repeating signal that could be a pulsar. This is structured, organized, visible evidence of artificial manipulation at the surface level. It's as if someone turned the lights on and said, "Look here." And we did. Efforts are already underway to collect more data. Infrared mapping, radio spectrum analysis, and future plans for laser-based directed communication are on the table. However, there's also a sense of urgency and awareness that if this surge marks the beginning of increased activity, then delays in response could mean missing critical developments. Some scientists have even proposed redirecting current missions or accelerating the timelines for interstellar probes. Proxima Centauri B, once a distant dot of possibility, has become the focal point for the next chapter of human discovery. In addition to the scientific, the philosophical implications are profound. For centuries, humanity has gazed into the stars and imagined companions among them. Religions, mythologies, and entire cultures have woven themselves around the idea of cosmic others. Now, with this luminous outburst from a nearby world, those imaginings might be edging toward reality. It invites reflection on our readiness, just technologically, but emotionally, and ethically to engage with a non-human intelligence. The flash of light also raises concerns regarding visibility and vulnerability. If a civilization has chosen to make itself known, it changes the dynamics of interstellar diplomacy and strategy. Visibility can be a strength, but it can also present danger. Why now? What prompted the sudden escalation in light output? Is it a celebration, a response, or something else entirely? Could they have detected our presence through our radio emissions, satellites, or light patterns? The James Webb Space Telescope was not designed to locate cities on other planets. Yet, it may have accomplished just that. Its sensitivity, resolution, and range allow it to detect fluctuations in brightness and spectral composition with unprecedented accuracy. But even the Finest instruments are only as good as our capacity to interpret their data. The current analysis suggests a consistent and measurable rise in synthetic lighting. But the narrative around what that means is still unfolding. Every fresh scan of Proxima Centauri B adds another layer of complexity to an increasingly shocking picture. Some voices within the scientific world are advocating for caution, reminding the public that anomalies may occasionally have prosaic explanations. The scientific community has focused on biochemical traces, atmospheric radio signals, and anomalies as the gold standard for finding extraterrestrial life. However, this event shifts that paradigm entirely. Instead of searching for subtle, frequently ambiguous signs, we are now confronted with a blindingly obvious option: artificial light on a planetary scale. This is not life hinted at by means of chemistry. It is civilization demonstrated by means of engineering. The implications have profound effects on entire fields, theoretical frameworks and studies, astrobiology, planetary science, and the search for extraterrestrial intelligence are now scrambling to accept this brand new type of evidence. Light emissions, particularly when observed in organized urban-like patterns, are a direct indication of energy use, technological sophistication, and coordinated social structure. This goes far beyond the threshold of mere life. It points toward structure, design, and cultural complexity. One particularly fascinating aspect is the timing of the surge. The light levels on Proxima B remained relatively constant over many years, shifting only within a predetermined range. Then the brightness appeared almost immediately, intensified exponentially. This abruptness is compelling. It might signify a planetary event, perhaps the result of a significant milestone such as global electrification, the launch of megaprojects, or the emergence of a post-industrial society. The scale and speed suggest it was not merely the lighting of a few cities, but the activation of a global system. It's as if the whole world reached a technological inflection point and burst into light overnight. The cause behind such a leap is fraught with controversy and speculation. One possibility is that the civilization reached a singularity-like moment, a technological or cultural breakthrough that allowed them to transform their energy infrastructure in a hurry. Perhaps a new limitless energy source was discovered or deployed, enabling widespread and instantaneous illumination. On Earth, the evolution of electricity transformed society in just a few decades. On Proxima B, the equivalent transformation might have taken place even more rapidly due to entirely different cultural or technological developments. Another possibility is the result of a centralized governing system, an advanced global administration capable of executing coordinated actions on a planetary scale. On Earth, such coordination would be virtually impossible due to political divisions and logistical challenges. However, a civilization that evolved under different social circumstances may have developed forms of governance optimized for unity and rapid deployment. This hints at not just intelligence, but a level of social harmony or control that allows for synchronized global decisions. The geometry of the lights adds another layer of intrigue. From orbit, Earth cities exhibit chaotic sprawl interspersed with rural darkness and wilderness. The patterns observed on Proxima B, by contrast, are more refined. The light clusters maintain regular distances from one another, and the connecting lines are geometrically consistent. This leads to the concept of cosmic-scale convergent evolution. Similar to how eyes independently developed multiple times on Earth, the layout of illuminated cities might reflect a convergent outcome of intelligent life. Regardless of the specific form consciousness takes, certain solutions appear frequently. The city becomes a kind of universal artifact, an inevitable consequence of intelligence interacting with both space and matter. Proxima's glow may be the cosmic equivalent of fingerprints, not of individuals, but of civilization itself. What stands out even more than the implication of the lights themselves is the infrastructure. To light up large swaths not only requires energy but also a method of delivery. Electrical grids, facilities for generation and maintenance personnel, or autonomous systems. All of these are necessary to maintain such illumination. This indicates that below the light, invisible to even the most powerful telescopes, lies a complex web of logistical and technical prowess. These lights are only the tip of an iceberg of planetary organization. Moreover, illumination on this scale demands storage and control. If Proxima B has a night-day cycle, as models suggest it does, then energy must be stored during daylight hours and efficiently redirected at night. This adds another layer of complexity. It demonstrates a comprehension of long-term planning, resource distribution, and possibly the effects of global climate. Lighting cities is not an isolated task. It is deeply tied to a broader system of environmental balance. Their capacity to do so sustainably and on such a scale may indicate planetary engineering maturity that Earth is just beginning to realize. There's also the matter of orientation. Light radiates outward, but it also reflects inward. On a planet filled with artificial lighting, they have to compete with a glimmering sky, heat emissions, and ecological feedback loops. Life, if it exists, on the surface alongside the technology, whether sentient or not, would be affected by this global increase in illumination. Have they adapted their surroundings to support both biodiversity and artificial infrastructure? Or have they chosen technological dominance over natural ecosystems? These are questions that will influence our beliefs about alien priorities, ethics, and long-term thinking. Equally intriguing is the possible cultural symbolism of light. On Earth, light has always carried metaphorical weight, symbolizing knowledge, enlightenment, safety, and celebration. Could it be that on Proxima B, light serves not only practical functions, but also spiritual or cultural roles? The timing, intensity, and arrangement of the illuminated zones may encode religious practices, values, or even artistic expression. Just as Earth's city lights reflect the rhythms of human life, peaking at dusk, dimming at dawn, these emissions could be cultural traces, a kind of planetary choreography in photons. If so, then we are witnessing not just energy output, but an aesthetic aspect of alien life. Some regions of Proxima B may glow not because they must, but because they choose to. A planetary-scale light show could be an expression of joy, remembrance, or performance. Possibly we are seeing a centennial festival, a unification event, or a planetary ritual. We have no idea where to begin. In that case, the 270% surge is not a byproduct of advancement. It is an encoded message not through speech, but through spectacle. This spectacle requires a return to the assumptions embedded in the Drake equation. That famous formula meant to estimate the number of detectable civilizations in our galaxy. It traditionally emphasizes communicative intent, such as radio signals, for instance. But the discovery of Proxima B reveals another class of civilizations, not trying to communicate but visible through their sheer activity. This passive detectability poses a threat to the very foundation of our search methods. It suggests that advanced life may be observable without deliberate intent to contact. But through the energetic footprint it leaves behind, and it raises a new parameter. Not just the longevity of communicative capability, but the duration of visibility through technological impact. A civilization may go silent yet remain luminous. In that light, Proxima B becomes an example of enduring presence, a testament to modern technology's capacity to echo across light years, even in the absence of a signal. Further analysis of these lights could even reveal hints about the civilization's timeline. Are the lights evenly distributed or expanding outward? Are some areas dimming while others grow? Such details could help astronomers construct a temporal model, a history of growth, potential rise, and saturation. This would be the first attempt to reconstruct a historical timeline of an alien civilization, from space based entirely on light, patterns, and expansion rates. This historical extrapolation may allow us to map out their societal evolution. Certain regions appear older or denser. It might indicate centers of origin or political capitals. If newer lights emerge in previously dark zones, we might infer migration, colonization, or terraforming efforts. In this way, Proxima B becomes not just a world of interest, but a living archaeological site unfolding in real time. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and let us know what you think about Proxima B's urban light surge, alien technology, or anomaly. We want to hear from you. Thank you for watching and see you next time.